Hello there, astronomy students. I want to show you how to complete this part of the lab activity today. This is the biggest part of the activity. This is kind of the part that makes it a lab. And what you're going to be doing is you're going to be completing some activity about crater counting, where you're going to have two images. Let me just show you here. There's going to be this image, which comes from the Martian northern hemisphere, and this image, which comes from the Martian southern hemisphere. And you're going to use those data to come up and figure out with an estimate as to how old is this area in the southern hemisphere versus this area in the northern hemisphere. Now, hopefully it's obvious this is younger because it's got fewer craters, and this is older because it's got more. But the question is, can we actually quantify this? Can we actually come up with an age? And you're going to do that by completing this table. Now, let me just be a little clear here. On this table, you'll notice that there are two columns here for the Martian northern hemisphere picture, and there are two columns here for the Martian southern hemisphere picture. Just so we're clear here as to how this is going to work, you're going to use the image to come up with data that you're going to enter into this column. It's going to be the number of craters you find in that image. And then there'll be a column here that's the same thing for the southern hemisphere image. And what you're going to put in the other two columns will be a calculation. All right, but we'll get there in just a second. So what you're going to do here is you're going to go back to each of those images. Let's just do southern hemisphere, for example. Okay, when you're on this image here, the question is asking, for example, how many, one of the columns is how many craters are between 64 and 128 kilometers across. Okay, to help you, I've made these little circles. The red one, there's a whole key here. This kind of purpley one here is 128 kilometers across. This one's 64 kilometers across. This one's whatever. You could either grab these guys with your mouse and move them around and, kind of measure these craters. Maybe you want to print this slide and, you measure with a little ruler or something like that. But what you want is you want to find out how many of the craters are between 64 and 128 kilometers across. And then that would go in this column right here. You would put for 64 to 128 kilometers, you would put that number right there. And then do the same thing for 32 to 64 kilometers across, 16 to 32 kilometers across, 8 to 16 kilometers across, and less than 8 kilometers across. Now, I get it, especially for those littler ones, you might kind of have to estimate a little bit. I mean, there's an awful lot of little craters in this diagram the more you look. Now, this northern hemisphere one, there aren't nearly as many. All right. Once you have this column collected with data, and this is going to take a little while. I mean, it's not a fast thing. And you have this column collected with data. You need to do the other ones where you're converting it from the number of craters you see in an image to the number of craters you would see if your image had covered 1 million square kilometers. Okay, each of these images is labeled how much they are, but they're both a weird number, but not as much as 1 million kilometers. On the bottom of the slide that you're watching here with this video embedded in it, I did put the actual equation you're going to be using here. Get the number of craters per 1 million kilometers by taking the number of craters you had in your image and multiplying it by a constant, that is 1 million divided by the area of your image that you got in that number down here. So like this one would be 812,000. Okay, you multiply across that and it'll just sort of standardize this. It'll say how many craters you have per million or whatever. All right, so you got 10 numbers to fill in there with just a calculation. All right, now you might remember that one of the goals of this class is working with more complicated diagrams, and this fits that pretty well here. But actually, it's pretty straightforward what we're going to be doing with this here. You have one such diagram for the northern hemisphere and one for the southern hemisphere image. And what I want you to do is plot the data that you just figured out. And I've made these little black dots here that are movable and that they'll help you with that. One of your ranges was from 0 to 8 kilometers. All halfway between 0 and 8 is 4. So use the one that I have here on 4 and just slide this up to, let's say you got 20 such craters per million kilometers. Notice that the y-axis here is craters per million kilometers. That's the calculation you did. So you'll take the craters that are 4 kilometers in diameter, which is close enough. That's representative of the range from 0 to 8. Let's say you got that many. By the way, notice that the scale is logarithmic, so it's a little bit weird. You got to count up. If it's 1 to 2 is a bigger gap than 2 to 3 and 3 to 4, and then it goes to 10, and then the next gap is 10 to 20, 20 to 30, 20 to 40, up to 100, and then it goes by hundreds, 100 to 200. If you don't know how to work with this paper, that would be a great question to ask me. We're all about learning things here, okay? So you're going to take these points here. Let's say this is okay. This is for 12 kilometers. That's kind of the middle of the range between 8 and 16. So we'll use that for your 8 to 16 range. And let's say you found this many. I don't know what that'd be like. Maybe you got whatever that works out to. Let's say that's three such craters per 100 of each million. And let's say you found one crater this size, okay? And then the other ones are just zero. All right. Then the step is take this line, this red line that's on here, and move it up and down. You can just do that with your arrow keys until it fits the lines, the points that worked over here. Now, anything that has a zero, don't worry about them. But you kind of get your best fit right here. And once you have it fitting as well as you can, you go to this right side x y index and you read off here like, oh, that's about a 2 billion-year-old surface. This right hand side here gives us the age. If all these dots had been higher up, and when we had moved the red line, maybe this fit better. Let me get my head out of the way here. Then something like maybe 4 billion would have worked out better. All right. But that's where you're going to get the answers that you're going to then enter over here on this slide. What did you get for the age of the surface of the Martian northern hemisphere? What did you get for the age of the Martian surface in the southern hemisphere? And hopefully you'll get that the Martian southern hemisphere is way older than the Martian northern hemisphere, but both are pretty old, okay? The northern hemisphere, remember, of Mars is Amazonian, so it is less than, what did we say, about 3 billion years old, but that still can be pretty old. Whereas the southern hemisphere tends to be Hesperian or Noachian, which is at least 3 billion, if not 4 billion years old. So you should get a pretty old age for the southern hemisphere. All right, that's what I needed you to see. Uh, I am a little bit scared of this online lab, but we'll figure it out. And I would have much rather we all been together for it, but what you got to do, what you got to do. All right, please let me know if you have any questions.